All right, so we're going to do some inverse functions. We already talked about inverse functions. They just mean that they're reflected in y equals x. We switch y and x. So first we got to review last lesson, which means that if I want the derivative of g of x, but really I want it at 7, first thing I need to do is find g prime of x. That's a product rule. So that's going to be 3 times 2 to the negative x plus the first term times the derivative of the second, and this is where there's some work to be done. So the derivative of the exponent is negative 1 times the original function, 2 to the negative x, times the natural logarithm of the base. Amazing.
Why?
Because it tells us to. Because that's the rule for natural or for logarithms. You take the derivative of the exponent times the original times the natural logarithm of the base. All right, but that's not what we're really finding. We're really finding it when it's 7. So 3 times 2 to the negative 7. I'm just going to write 21 because we're all smart, and we can go 3 times 7. If not, I feel bad for you. And then we've got negative natural logarithm of 2 times 2 to the negative 7. And then you just put that in your calculator. Or leave it. I guess we could leave it. Do you want to leave it? Should we leave it?
Yes.
Let's leave it. Let's leave it. All right. Let's see. We've got a common factor of 2 to the negative 7, actually. So why don't we just pull that out? 2 to the negative 7. 3, actually that'll be 3 minus 21 ln yeah, that's right, ln of 2. And then really, that's like 3 minus 21 times the natural logarithm of 2 all over 2 to the power of 7, which is really, I don't know, we're going to see how good we are. I changed my mind. Changed my mind. Oh, okay. 2, 4, 8, 16, 32, 64, 128.
Sure, whatever you say.
Oh, I like that you trust me. Might be unwarranted, but I'm pretty sure this time I'm right. If any of you had brought your calculators, you would know.
Leave it.
I have never said leave your calculator. I have always said
No,
right.
leave the answer.
And then I changed my mind, right? I was like, oh, let's simplify.
So how are we supposed to be? So plug it in. Then we got the calculator open right there.
But I didn't use it. Oh my gosh. Fine. Okay, look. 2 to the power of 7. Hey, look, I'm right. Woo! Go us. Uh-oh. Guys, it won't.
Unclick the no,
It won't let me. Reset Zoom. It literally won't let me. Oh my god, no. Exit try. Whew, that was a pain. Okay, there we go. That made me annoyed. Alright, let's do the actual lesson for real now. No, I don't want to. 3.6. Derivatives of inverse functions. So, earlier in your life, you allegedly learned, no. Let's take a moment to remember what an inverse function is. I already asked you, and you already told me. Yeah, and what did it really mean? It meant that, like, we switched y and x. If we're switching y and x, then really, what that means is that numerically we can define it as the function whose domain is the, next line, is the range of f of x and whose range is the domain of f of x. In other words, what do we do?
Switch the domain and the range.
Yeah, switch x and y, which ultimately also means switch the domain and range. You should have done this, allegedly. Thank God. It's about time. I don't want to talk about your keys. All right, graphical representation. All right, let's draw something. Let's draw a picture together. I like drawing pictures with you guys. It's always fun. All right. So this is my line, y equals x. And then if I have my original function, let's say just, let's just do something easy, like a line like this, where maybe it goes from like -1 and 1 to like, let's call that -3 and 3? No, 2. Yeah, it's not perfectly to scale, don't worry about it. All right. Now, if I were to figure out the representation of that, that means that this point here that is at -1, 1 would go to 1, -1. What? Oh. And then this point here that's at -3, 2 would go to the point 2. 1, 2, 3. They go to like this point here, which is the point 2, -3. Because we switched it, right?
Why are you talking like that?
I have no idea, okay? Because I'm sick and on lots of meds. Reflect in line.
That's better. I'm on drugs.
I am on drugs, okay? The good drugs. I'm on the good drugs, not the pot. We'll deal with that later, I'm sure. All right, fair enough. Canonical representation of the inverse. No comment. We're on YouTube. So, if f inverse of x is the inverse of f of x, then, are you ready for it? F of f inverse of x is just x. And f inverse of f of x is also x. We're just switching x and y. Yes. The drawing, I don't know. If you don't understand the drawing, you probably need to go and check with your pre-calc teacher. Actually, realistically, that's probably like algebra 2, algebra 1. It's a while ago. Okay. It was allegedly in those classes.
I don't recognize which one is X and which one is Y.
Oh, I see.
Equal signs.
So both are eggs.
Both are X.
What do you, no. Where?
You said both of them equal eggs.
Where? Which
The
one?
inverse of f of x, the f of x.
Like here, here, here,
Ah,
here,
see,
here,
there,
here,
there,
here,
there.
here.
See how both of them are
Here.
equal to x.
I know, right?
Oh, so that's what they were asking, and you said no.
No, I said where. I always said where. There's a video proof. We're gonna watch it later.
We can. Okay, let's look
No.
at that.
So all it means is that if I take the f of the f inverse, basically it cancels out and we just get x. That's what it means. And if I take the f inverse of the f of x, I just get x. So basically, like what I'm trying to get you to see is that this stuff cancels out.
That is f of that.
It cancels out.
No, please.
I miss.
I will say you.
All right. Can we continue?
No, wait.
Yes, we can. Look, those boys are talking about. Yakiman, I want you to take that thing and put it somewhere else. No, somewhere where you can't reach it. Because if you can reach it, you're going to play with it again. All right. Consider the two functions f of x and g of x represented numerically below. Answer the questions that follow. All right, let's see if we can get it all on the same page here. I think we can. What is this stupid drawing thing? I don't like it. Go away. All right. So, complete the table of values. X is
3.
3, and f inverse would be -2, because we switched x and y. Now, I understand this is a little bit confusing because it just says x, but the f inverse part is what gives us away that we're switching it. So then for the other point, it would be 2 and 1. Look at us go. We're incredible, eh? All right. Should we do it for g? Let's do it for G. Let's do it for G. Ready? Okay. -2 and 1, or 1 and -2. And then I would write it the other way. So it's, yeah.
When it's asked us to find the number, we look for that value in the geometry.
When it's inverse, you're gonna look for, like, when it says G inverse of X, you're gonna go look for the X value, not the Y. Normally we'd look for the Y value, right? So that was the silentest sneeze ever. Let's try some of these now. What? Okay, well, hold on. So here, I got G inverse of -2. Okay, so G inverse of -2 means that that's 1,
Why?
because I'm looking for the X value here. So it's there. Okay,
And f of 1.
which means I'm finding f of 1, and f of 1 is, yes. We are geniuses, or confused. One of the two.
Both, a little bit of both.
A little bit of both. All right, we can live with a little bit of both. All right, this one, we're finding f of 1. We already know that's 2. And then I want to find f inverse of 2, which means that I go to the y value of 2 and I find, oh, it's 1. Right?
But we already learned this. If f of 1, if the inverse.
I agree.
Okay. You showed us the rule.
I agree. But now we're just like doing it again, practicing. F inverse of 2. F inverse of 2 is really 1, right? Because we find the 2 in the y and we go, oh, it's 1. And then we need to find G inverse of 1. And we go to that, go to -2. I don't know why it needs to sound, but it feels like it needs to sound.
You really are hard.
Excuse you. Excuse you. All right. G inverse of 1. I mean, truthfully, I am. So, G inverse of 1. We go up here, -2.
I don't lie.
And then I would need to find G of -2. G of -2 is 1. And then I need to find F inverse of 1.
Why do you know G of -2?
Because G of -2 means I'm finding G of -2 the normal way. Because it's just G. And then I found F inverse of 1, which means, I don't know. Right? If I look up here, there is no 1 here. So we have to just be like, hey, you know what? It's, I don't know, not given.
Are you sure you said this?
Guys, look, there's no 1 in this column. So yes.
So we read on the
No, you just say you don't know. There's not enough information. With a little bit of information we were given, there's not enough. Now, why did I bother showing you this one then? Hey guys, Benji, why did I show you this one? To show you that this step didn't matter. Remember G of G inverse of 1? That just cancels. So we actually were just finding this all from the start. See, we started with 1, got to -2, then -2 got us back to 1. Oh. So we were just finding F inverse of 1. All right, let's do it. Given that below is the relationship that exists when a composite function is formed using a function and its inverse, use the chain rule to differentiate both sides of the equation and find the formula for the derivative of F inverse of 1. So we're going to do a proof. Woo, we like proofs. F of F inverse of X is equal to X. Remember that was the claim we made earlier? Let's prove it. Let's take the derivative of both sides. Let's start with the easy side. What's the derivative of X? Thank God. All right, on the other side, we gotta take the derivative of this. So, no, it's a chain rule. Derivative of the outside means it's F prime of F inverse of X, because that part doesn't change, times the derivative of the inside. Now this is kind of awkward to write, but let's do our best. F inverse of X prime. We're going to write it that way because it's kind of awkward to write it. Could write d dx as well.
On chain, not we have an exponent besides the parentheses. No.
No. That's one of the ways. There's lots of different chain rules. It just means outside, inside function. Composite functions are when we need chain rule. Okay, so this is like just like when We were trying to figure out what the derivative of f inverse is, which means that I need to divide both sides now by f prime of f inverse of x.
Why?
Well, because we're trying to solve for the derivative, right, of the inverse. That's what we're trying to find. So these ones cancel. Amazing.
And why did you divide by that?
Because that's how I get f inverse prime by itself. So then I'm going to write it differently just to keep you on your toes again. D dx of f inverse of x is equal to 1 over f prime of f inverse of x. Bam, look at that. We got ourselves a formula. Woo. Now we can just use it. Right? Right. Right.
See, right now we're not genius. Right now we're only confused. Why did you change it?
Change what?
DDX.
Just to keep you on your toes. And honestly, I kind of prefer that notation. Don't you think that looks nicer than bracket f inverse of x bracket prime?
Yes.
I feel like this is ugly.
D over
This is
DX,
prettier.
But can we just do the same thing? DDX on the other side.
I mean, if you wanted to.
D over-
It's guys, you're going to use it this way, so let's write it this way, okay? It's going to help you more. Trust me.
D over DDX is
D over dx, not d over ddx.
D over DX is inverse.
No, d over dx
Why
is a
la
derivative.
fórmula sería x plus w at the end. You read all the books.
Nope. Read a lot of them, but no. All right, so let's actually try this. Let's try it, guys, and I think it'll help you make more sense, okay? Suppose that f of x is equal to this thing, and f prime of negative 2 equals 3. What is the value of f inverse of negative 4 prime? Okay, so first, let's go ahead and figure out what that's going to be. So we're going to switch x and y, right? So we've got x equals 3y plus 2, and then how do we do this? We need to solve for y again, right? That's how we find the inverse function. So this is going to be x minus 2 over 3 equals y. Are we okay with that? Do we need all the fun steps?
Yeah.
Thank God. All right. So then, actually, do we even need that?
We need that.
I mean, you know what? I'm going to move it over here. It's not bad that we have it, but the truth is, we actually don't have to solve it. We could plug it in right here, now that I think about it. We could just plug in the negative 4 here. So we could say like negative 4 equals 3y plus 2. And then we're going to solve for y. So we're going to get negative 6 equals 3y. Y is equal to negative 2. Beautiful. Beautiful. All right, so we've got our point like basically negative 4, negative 2. Now what we need to do is find it. So d dx of f inverse of negative 4 is equal to 1 over f prime of f inverse of negative 4. Now, we just figured out that f inverse of negative 4 is what?
Negative.
Right. So it's going to be f prime of negative 2. Right? Because f prime of negative, or f inverse of negative 4 is negative 2. Then we just need to find this. And it tells us that f prime of negative 2 is equal to what?
3.
Woo, 1/3. How we doing? Anybody lost?
And the other side. D
No.
over DX.
This side? Oh, that just means it's the derivative.
But why did we get 1/3? We did it.
Here, okay, you know what? Fine, we'll write it this way.
Please stop doing
Does that make you feel better?
How did we get to 1/3? Porque arriba le que
Yeah, up here it tells us the derivative of negative 2 is 3. So I'm just making that substitution. All right.
Wait.
Oh, wait. Wait. Yeah, it's a negative 4. Oh, your class isn't the class that did this, is it? The other class, they kept making fun of me, and I was like, fine, you come right. And I had like 6 of them try, and I was still the neatest of all 6 of them. I was like, suckers. The other person that came even close was Vero, because she actually writes her notes on her computer as well. So she was close. It's harder than you think.
Of course, no. Can I try? No, it won't.
Afterwards, yes. Afterwards you can. We're not going to do it on the video.
I need to-
All right, so now we've got x, f, g, f prime, and g prime. Given to the left is a table of values for f, g, f prime, g prime. Use the values in the table to find each indicated value in the boxes below. Remember, we love chart questions because you have to know what you're doing or it shows. So, all right. Matthias, it's not so funny. Flirt later. All right. So if we look at this, what do we kind of need to know?
Is it 1?
Well, hang on. Let's find some stuff. So f of 1 is going to be 3, which means that f inverse of 3 is going to be 1, right? Like this is how this reads. They're backwards,
How do
okay?
we know f of 1 is 3?
Well, because I looked up here. Sorry. Good point. f 1, 3, right? Just looking at those two. And then when I'm doing the inverse, I'm flipping them. So this is x, this is y now. Okay?
You should write f of x because it's not discontinuous. Like on the top of the table.
Like you want f of x here?
Yeah.
Okay. Sorry. There you go. All right, so now let's find the derivative. So d dx of f inverse of 3 is really equal to 1 over the derivative of f inverse of 3. And we just figured out that f inverse of 3 is what?
1.
Excellent. And what is f prime of 1?
F prime of 1 is 2.
So it is 1/2. So d dx of f inverse of 3 equals 1/2. We're amazing. So this one here, I need to figure out what's going to be equal to -2, right? So g of what gives me -2? There's -2, so it's 1. So g of 1 equals -2, meaning that g inverse of -2 is going to equal 1. Make sense?
Yes, sir.
Yep.
Sorry to come back to the lab. How do you know that f prime of 1 is that?
F of 1 isn't that. F prime of 1 is.
Yeah, how do you know?
Because I go down here,
Sorry. Okay.
and then I go over to f prime. That's okay. All right, so it's the same way that I got these, right? G of something equals -2. I go find when y is -2. Oh, hey, it's 1. And then I reverse them when I'm doing the inverse. Perfect. So now let's find the derivative. So d dx of g inverse of -2 is equal to 1 over g prime of g inverse of -2. All right, let's work on this. Now, g inverse of -2 we just figured out is what?
1.
1. And what is g prime of 1? There's my 1. There's my g prime. It's a 1. So it's 1 over 1, or really it's just 1. I guess I should write this again. d dx of g inverse of -2.
That is very long.
I mean, it's not really that long if you think about it. It's more just that there's lots to think about. I'm not gonna lie to you guys. This is my least favorite stuff too because it's abstract. You're like reversing them all in your head. I don't love it either. I'm sorry.
And also writing, the
I don't know why you had to announce it, but good luck.
also, the writing 3 over the x.
Hang on, guys, hang on. Let's don't all start talking. This is why your lesson takes so long. All right, so we've got another table question because we love them, or at least I do, because they make me know if you know what you think you know. I know. That's good. All right, so x, f, g, f prime, and g prime. All right, cool. We got a table. We got a bunch of answers for that table. So then we're going to find these things. G inverse of 1 prime. So really, what are the things that we... Oh, well, hang on. Let's back it up. Find the equation of the line tangent. Okay, so we need pot and sod. We need some pot and sod. Okay, but...
I hate pot and salt. They're like those.
Why do you hate pot and sod? Pot and sod are great. Okay?
Yeah, we can tell. But it's very twisty.
Pot is 1. And we're doing G, right?
Yes.
No.
G prime. No, it's G.
It is G. So it should be -2. And my SOT is going to be 1.
How do you know?
That doesn't seem right. No, it's not. That's ridiculous.
No, it's flipped. It's -2,1 instead of 1.
Yeah. This is wrong. This is all wrong.
What?
All wrong. Okay. Let me back it up. Okay, so let's go back and do it the way we did it before. So what I want to figure out here is like G of something equals 1, which means that it's 3. Which means that G inverse of 3 equals 1. No,
What?
other way around.
What?
G inverse of 3 equals 1. There we go.
Exactly what you already have.
Which means that the pot is 1 and 3.
Right.
1 and 3. Right there. Right? It's 1 and 3.
Okay.
Because it's we're doing it to the graph of G inverse. So we got to switch Y and X, guys. That's why. That's why I write. If I don't write this, I screw it up every time. Did you know
Why
that?
is that first one wrong?
Yeah, we've seen that.
Because that's our
All right. So now let's actually find the derivative of that thing. So we got to go like d dx of G inverse of 1 equals 1 over G prime of G inverse of 1. And we just figured out what that is. So it's G prime of G inverse of 1 is really,
1.
damn it, I did write it backwards again. Frick. I had it right the first time, and then you made me change it, and it was wrong.
No, I told you, we wrote the exact same thing. If you look back
Yes,
at the
you're right.
video-
You were right, she is wrong. And I was both. I was right and wrong.
I was making fun of
No, you
I know you made fun of me, and it flustered me. Okay, so it's 3. And G prime of 3, where is 3? -2. Okay, so this is going to be negative 1/2. Okay, all right, we got somewhere. Oh, that was annoying. Okay, so y minus the y coordinate, which is 3, equals the slope, which is -1/2, of x minus the x coordinate, which is 1. So x minus 1.
That is that sort. I know.
Guys, you missed.
Yo prefiero en español.
Salud.
Gracias.
I love when you say thank you in Spanish.
I think it's because I studied history. Do you know where bless you comes from?
Weird.
They thought you were going to die when you sneezed because of the Black Death. And so they would literally be like, bless you, hoping that they would literally shove your soul back in your body. So I'm like, that's dark. Let's just wish people like, you know, health, love, and money. That's better. Anyways, like I said, I studied history. All right. So now let's estimate the value of f prime of 2 based on the value. What conclusion can we make about the graph of f when x equals 2? So remember, whenever we're estimating, usually we're doing a secant line, right? Or we use a tangent line to estimate. Those are the two ways we've done it. So this time we're going to do a secant line. So it's going to be like y2 minus y1 over x2 minus x1. Now if I'm using 2,
It's in between.
it's between 1 and 3. So we should probably use those ones. And we're doing it for f. So it's going to be like 1, 3 and 3, 1. So those are our 2 points. So let's go ahead. Let's just write those down real quick. 1, 3, 3, 1. That's kind of obnoxious, but whatever. So we could do it as like, I'm going to make it the first one y2, just to mess with you. It doesn't matter the order, as long as we keep it the same. 1 minus 3. And we get 2 over -2. Now just to prove it to you, let's reverse it. If I do 1 minus 3 over 3 minus 1, I get -2 over 2.
Just -1.
What did you read?
Samesies. Exactly. Samesies. The whole point is just to remind you that it doesn't matter which way you do it. We're going to get -1. All right, what does that mean? Well, this means that f prime of 2 is less than 0. Therefore, f of x is doing what?
Decreasing.
Yeah, decreasing. We got it. It's decreasing specifically at x equals 2. know I'm weird. It's okay. All right, so let's take a look at this last one. Estimate the value of g prime of -1. Based on that value, a conclusion can be reached about the graph of g when x equals -1. So, same kind of idea as what we just did. So g prime of -1 can be estimated. Let's go figure out those points. So at -1, it's going to be between these two, but it's for g. So we're going to get -2 and 2 and 0 and 0 and what? 0 and -3. I already forgot what they were.
What?
No,
Negative-
if we're looking at G prime,
What was it again? -2 and 2. And what was the other one?
It's -2 and 0 for.
And then, yeah, so 0 and -3 is the other point. I like to write out the points because it's easier to do that, right?
Where did we get 0 and -3? Are we looking at?
Yeah, we're looking up here. So we're looking at -1, which lies right here between these two.
Yeah.
So we're going to use these two coordinates to figure out what the estimation is.
Okay.
Okay,
So it's
perfect. So that means we're going to get like -3 minus 2 over 0 minus -2, which is really -5 over 2. All right, what does that mean? G inverse of, or not G inverse, G prime of -1 is less than 0. Therefore, G of -1 is decreasing.
yes, we are. There is this practice. Yuppie. We never do practice.
Well, maybe you should try doing the practice.